Good morning, dear students. My name is Ferhan Mazher, and today is 4th of November 2021, and the day is Thursday. And right now, I am with the 11th Cambridge class, and the subject we are studying is Physics 5054. Today, we have set our hearts to solve an AT paper. We call it paper 4. Today, we have selected October November 2019 ATP paper. The paper belongs from the zone 1. So it's 4-1, it's a variant 1. So let's start this paper. And the time allowed for this paper is 1 hour. So the first question coming up on your screen, and let me read it from the Okay, so this is October, November 2019 4-1 paper. The time allowed is 1 hour. We call it alternative to practical. So let's go to the question. He says, a student is asked to find the focal length f of a lens. He uses an arrow-shaped slit in a piece of card as an object, as shown in the figure 1.1. The object is placed at one end of a meter rule, and the lens is fixed a distance u from the object, as shown on the figure 1.2. The slit is illuminated from behind using a lamp. A screen is then placed on the meter rule so that a sharp, focused image of the arrow is formed. The distance v from the lens to the screen is then measured. So here is that diagram. Here is that arrangement. You can say here is that object which is in the shape of an arrow, and behind it we have put a lamp so it becomes illuminated. Then here you have a convex lens, and here you have your screen. The distance between the object and the lens is represented with the u, and the distance between the lens and the screen, I mean the image, will be here. So that distance is represented with the v. So he says, explain how the student ensures that the image is sharply focused on the screen. So the student will move, the student will move the screen forward and backward. He can move it forward, he can move it backward. He will do the hit and trial until he gets a very sharp and focused and clear image on that screen. So he will then stop the screen at that point. So he can move the screen forward, backward, so that he's looking for a point where the image is very clear. Okay. So he moves the screen. Let me show you my answer. I have written this answer. So let me show you. He moves the screen forward and backward until a clear image is formed on the screen. So he moves the screen forward and backward until a clear image is formed on the screen. Okay, so the next part, that was the question number 1 and its A part. And now the question number 1 and its B part is showing up on your screen. But let me go to the question paper so we can. So here we go. Figure 1.3 is a full-scale diagram showing the positions of the object, center of lens, and screen when the screen when the sharp focused image is obtained. So this is the position of the object, this is the position of the lens, center of the lens, and this is the position of the screen. And this is full-scale diagram. Take measurements from the figure 1.3 to find u and v. You know the u is this distance, the object from the lens, that is u. So put a scale here and measure how much is this length. And I put it and I found it to be 6 centimeters. So here you will write 6 centimeters. Then with the help of the scale, put the scale here and check what's the distance between the lens and the screen. That will be your V. So when I did this, this was 4.3. Your answers will be little. If you have a photocopy of this paper, So when you will measure it, it will be little less than what correct answers are, because when we photocopy the paper, the diagram actually a little bit shrinks, but that's not a big deal, so then the question is, the focal length of the lens is given by the equation f is equals to uv divided by u plus v. Calculate f using your measurements in the figure B first part. So we have the value of the u, we have the value of the v. So we just have to substitute the value of the u and the v in this formula, and we will be able to calculate the value of that. The u value is 6 and the v value is 4.3. Let me show you. I have done this on a paper. So here we have. So here we go. So the u value is 6, the v value is 4.3. The f will be equals to 6 into 4.3 divided by 6 plus 4.3. So upstairs you will have 25.8 and downstairs you will have 10.3. So when you divide 25.8 with the 10.3, you get 2.5. So 2.5 centimeter is the focal length. Then the third part is that it's a B third part. It says, suggest one way that the student ensures that his value for F is accurate. So what he can do, he can repeat that experiment again and again and find every time the value of the F, and then take the average value of the F. For example, he did the experiment 3 times and he found that the value of the F is this A value, B value, C value. Then he add them, divide with 3. So then this is how he find the average value, and that will be more, accurate. So let's have a look at the markings. So, my dear students, you can see that the marking scheme is showing up on your screen. And this is the marking scheme for the question number 1. And what you can do, you can pause the video and have a good look at this marking scheme. It's very important to compare your answers with the marking scheme. A student carries out an experiment to find the mass of a meter rule. She uses a number of identical metal rings and a pivot. Each ring has a mass of 3.3 grams. The apparatus is set up as shown in the figure 2.1. So here we have a pivot, and this is the meter rule, which is 100 centimeter long. And at the point of 45 centimeter, they have put a pivot below that point. And at a mark of 5 centimeter, they are putting rings. So metal rings they are putting, and they are stacking the metal rings over each other. And so it's at 5 centimeter mark. The distance between the pivot and this point will be 5 minus 45, and it will be 40. And here somewhere we will have the center of gravity. The center of gravity will be at the mark of 50 centimeter. So the distance between the center of gravity of this meter rule and the pivot is 5 centimeter. Okay. The student places the pivot under the 45 centimeter mark on the meter rule. She then places rings one at a time on the meter rule at point A, 5 centimeter along the rule. She adjusts the number of rings until the rule is as close to balance as possible. And she records the number n of the rings needed to balance the rule. The rings are circular with the metal hole as central hole, as shown in the figure 2.2. So it's a full scale diagram. He says measure the outer diameter of the ring. So when he uses the word measure, it means that you have to use a meter rule and measure from this point to this point. So check from this point to this point, where you find the maximum distance between these 2 points on the circumference of the big circle. That will be the outer diameter. So when I did this was approximately 2.2 centimeter. So the outer diameter is approximately 2.2 centimeter. He says figure 2.3 shows a section of the meter rule. On the figure 2.3, sorry, draw one ring correctly placed at the 5 centimeter mark. So here I have to, the center will be here, so I have to place the ring here. I have to show the ring here by drawing it. So let me show you. Okay. So here you can see I have tried to make that ring, and this is how you will draw that ring. That ring has a hole in it. So this is how you will, the center of the ring will be at the 5 centimeter mark. So that was that question. Okay. The outer diameter is 2.2 centimeter. And this is how you draw it. The next question is explain why the student adds the rings carefully, one at a time. So why you place the rings very carefully? Because I want to know exactly the weight at which the rule will be balanced. Plus, uh, when you place, you want to make sure that the rings are piled up over each other and they remain in their position. 5 centimeter mark, that should be at the center of that ring. So that's why they slowly put the rings. So I think that let me show you my answer. Explain why the student adds the rings carefully, one at a time. My answer is to ensure that the rings are placed in the correct position. The distance L between the pivot and the point A is changed by moving the pivot closer to A. A student repeats the experiment for different values of L and draw a table of results as shown in the figure 2.1. So here you can see a table is given to us. Here the values of the L are given, and here the N, I means the number of the rings, they are given. 4 rings, 9 rings, 17 rings, 28 rings, 23, 70 rings. He says on the figure 2.4 on the page 7, draw a graph of N on the y-axis. The number of rings will be on the y-axis against the L, which is the length in centimeters on the x-axis. Start your axis from 0, 0. Draw the best fit curve. So that is question number 4. So on the next page, we have that, we have that graph. So you can see this is that graph on which we have to work. So let me show you. So here you can see that on the graph paper, I have marked we call it label the axis. So here on this axis, we will have the number of rings. That is represented with the N. So here you can see I've written 10, 20, 30, 40, 50, 60, 70, and 80. And on the x-axis, we have represented the length, the small l, and that is in centimeters. And it will go from 10, 20, 30, and 40. Then I will plot the points. The first point here, that is 40, that point is 15,70. And then we have this point, and this point is 20,43. And then I have this point, and this point is 25,28. Okay. So then we have this point, and that is 30, 17. And then you have this point, which is 35, 9. And then you have this point, which is 40, 4. So this is how you will, these are the coordinates that I have taken from the table 2.1, and I have plotted them on the graph paper. And then I will join them with the free hand, and I have tried to draw a line, a curve of the best fit. So hopefully you understand. Okay. Then their question is, they say, use your graph. That's the second part of the B. He says, use your graph to estimate the number N18 of ring required to balance the rule when L is 18 centimeter. Show you're working clearly on your graph. So we have to show this on the graph. So this is that our graph, and here is here. So they have told us that the L is 18 centimeters. So here is the 18 centimeter. From here, I come to the graph. And from here, I go to the number of rings. The number of rings are 52, 53. So you can see I have written here 52. Then they say that's the next part is the third part. He says the theory suggests that the mass m of the meter rule is given by the equation m is equals to 3.3 N18 multiply L divided by 45 minus L. So using your answers in the second part, calculate the value of the m, giving your answer to two significant figures. So the m will be 3.3 multiply N18 is 52 multiply L is 18 centimeter, and downstairs we will have 45 minus 18. So when you find, you enter these values in your calculator, you get 114.4. And but in the question, you can see that here I have underlined that sentence also. He says the answer to two significant figures. So the 114 into two significant figure will be 110. So 110 gram is the answer. Next question is, he says, name a piece of apparatus that can be used to check whether the theory is correct. So we need a balance on which we can measure the mass of the meter rule. So just one way in which this method of measuring the mass m of the meter rule can be improved. So using rings of smaller mass. So if your rings are larger, so instead of using larger rings, use smaller rings. That will make your measurements more accurate. So use the rings of smaller mass. So we are done with the question number 2. Let's have a look at the marking scheme. Question number 2. My dear students, whole of the question number 2 is showing up on your screen. So what you can do is you can stop the video, pause the video and have a good look at this marking scheme. To check your answers with the marking scheme is very, very, very important. So this was that question. So the whole question is coming up on your screen. You see, we have done this question. So totally it was 13 marks. Okay. So we are done with the graph part. Okay. Then he says, we are done with the second part. Okay. No, sorry, the first part. We have drawn that. Okay. Then we have these questions on the, okay. Use your graph to estimate the number n18 of the rings required to balance the rule. When L is 18, show working clearly. So you can see that we will put here 52, and I will put that value here, and I got 114.4, and that was 110. Okay. So the mass was 110 gram. Then the question was, name a piece of apparatus that can be used to check whether the theory is correct. You see, to check the mass of the ruler, I can use, balance. And one thing which we used was, so that's one way in which this method of measuring the mass m of the meter rule can be improved. And we give the answer, use rings of smaller mass. So I was taking you to the marking scheme. So here you see the marking scheme is showing up. I told you to stop this video, pause this video, and have a good look at this marking scheme. Okay, now we are going to the next question. The next question is question number 3. He says, a student investigates how the resistance of a filament lamp changes as the potential difference V across its changes. He uses the circuit shown in the figure 3.1. On the figure 3.1, draw the symbol for an ammeter and a symbol for a voltmeter in the correct position for this investigation. So I will put an ammeter here in series, and I will put a voltmeter here parallel to this lamp. So let me show you my answers so you can understand. Here you can see that I have put an ammeter here, which is in series with the lamp. And here we have put a voltmeter. That voltmeter is parallel to the lamp. This is how you connect those instruments. And okay, so the next question. He says, the question is, the student takes 2 different sets of readings of current and the potential difference. Suggest how he adjusts his circuit to do this. So first of all, first the resistors. You know, here we have a variable resistor. You know that we have variable resistor here. Here you have the variable resistor. So for the first reading, what you will do, you will make the resistance of the variable resistor maximum, and you switch on the current, and then you note down what is the reading on the ammeter and what is the reading on the voltmeter. Okay. And after that, you can gradually decrease the variable resistor and note down the different values of voltage and the ammeter. Ammeter will tell you how much current is flowing through the lamp, and the voltmeter will tell you that how much voltage is taken by that lamp. So my answer here, first the resistance of the variable resistor is maximum. Then for second reading, reduce its value. I mean, reduce the resistance. The student takes 2 different sets of readings of current and potential difference, just how he adjusts the circuit to do this. So we are done with that. He adjusts the circuit so that the voltmeter shows 4 volt, and he reads the ammeter. He repeats the experiment at 8 volt. So what is the reading exactly right now? You can see here, this is 1 point, and here we have 1.5. So 1, 2, 3, 4, 5. So basically it is 1.2. The reading is 1.2 volt. Now check what is the reading here. The reading here is, so here you have, okay. So it's like 1.65, I think. Yeah, 1.65. From this, I am telling you. And here you will note that. Okay, so let's move to the next part of the question. This is the third part of the question. He says, use the equations R is equals to V by I. So to calculate the resistance R of the lamp at 4 volt and the 8 volt, state the until in your answer. State the unit in your answer, sorry. So R will be, according to this table we have. Where is that? Where is that table? Let me show you. So when the voltage, that is the, I was looking where that. So when the voltage is 4, the current is 1.2. So the voltage is 4 and the current is 1.2, and the R formula is V by I. So 4 divided by 1.2, and that will be 3.3. So the resistance will be 3.3. Now, when the voltage is 8 volt, what will be the resistance? So, R is equals to V by I. So the voltage drop here is 8 volt and the I is 1.65 ampere. So divide 8 with the 1.65, you get 4.85. So this is how you do this part. And the next part is C part. It says state 2 physical changes in the lamp that are observed in the potential as the potential difference V is increased. Okay, state 2 physical changes in the lamp and that were observed as the potential difference V across V is increased, and filament becomes brighter. Okay, so state 2 physical changes in the lamp that are observed in the potential difference V is increased. So when you will increase the state 2 physical changes in the lamp that are observed as the potential difference V is increased. So you see, when you increase the voltage, the filament will become hotter. It will become red hot. The filament becomes hotter, brighter, and it becomes very hot and it becomes brighter. Then the second will be the filament becomes hotter. So there two things will happen with the filament. Um, One, it becomes brighter, and the second is it becomes hotter. So my dear student, that was question number 3. So let's have a look at the marking scheme. Question number 3. So my dear students, question number 3 is showing up on your screen. You can pause the video and have your time with this marking scheme. It's very, very important that you check your answers, you compare your answers with the marking scheme. So you can pause the video. So this is question number 3, and you can have a good look at these questions. This question was of 7 marks. Okay, so now we are going to question number 4. It says a student has a thermometer which has no temperature markings as shown in the figure 4.1. So it's a this is a thermometer and there is no markings on it. So it's not calibrated. He finds the length of the liquid column when the temperature is 0 degrees centigrade. And we call this ice point, and state the apparatus he needs to do this and explain how he uses his apparatus. You may use a diagram if you wish. Okay, so it's a let me show you this question. This question is of 2 marks. So let me show you my answer. Okay. So here comes. Here you can see we have shown a funnel, and inside that funnel, I have shown ice cubes, and that ice is melting. I have placed a beaker below that funnel, and here we have a thermometer, and you can see that the ice is melting. Place the thermometer in a funnel which has melting ice. When length of the mercury column becomes steady, note down its length. So when you place your thermometer in the melting ice, obviously the column of the mercury will go down, and you observe it. When it becomes steady, then that is the point which is known as the ice point. So mark that position, and if you want to measure that length, you can measure that length. That will be the ice point. So you can measure the length of the mercury at that point. Then we have the next question and next part, I mean. Let me show you. That was the A part, and this was the 2 marks. And here we go. We have, he says he finds the length of the liquid column when the temperature is 100 degrees centigrade. State the apparatus he needs to do this and explain how he uses his apparatus. You may use a diagram if you wish. It's a 2-mark question. Let me reduce the size. So it's a 2-mark question. It's the B part. And let me show you my answer. I have done this. So we want to find out the steam point. So here you can see I have shown a retort stand. This is the retort stand. And here with the help of a clamp, I'm holding a thermometer. And here we have a beaker. In this beaker, we have water. Here we have a burner. And this water is boiling and its steam is coming out. So the bulb of this thermometer is in the steam. And you will observe that when you will place the thermometer in the steam, the level of the mercury will go up. You wait for some time. When the level of the mercury will go up, 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 and when it becomes steady, just mark on the thermometer, and that will be the steam point, and you can measure the length of the mercury column. So my answer is thermometer is placed in steam of the boiling water. When the length of the mercury becomes steady, note it. So measure the length of the mercury when the level of the mercury becomes steady, and thermometer is in the steam of the boiling water. So okay, so the next part is the C part. He says suggest how he then uses his thermometer to find the room temperature. You see, once you have there are 2 methods which we can use if you know the the length of the ice point, and if you know the length of the mercury at the steam point, and then if you know the length of the mercury at the room temperature, then we have a formula and we can use that. If you want that formula, let me write that formula for you. So let me write that formula for you. And okay, the formula is that let the room temperature is theta. So the formula will be L theta. I will write here theta minus L naught. L naught means the length of the mercury when the temperature is 0. I mean the ice point. And then you here downstairs you have L100. L100 means the length of the mercury when the temperature is 100 minus the L naught. L naught means the length of the mercury when the temperature is 0. So here we will have theta by 100. This is one way of writing this answer. If you know the length of the mercury at the room temperature, and if you know the length of the mercury at the ice point, and you know the length of the mercury at the steam point, then you can use this formula. Theta will be your, these are the three lengths, L theta, L0, L100, L0. These are the lengths, and here this temperature, room temperature, you can find the theta value. This is one method. Another method which I have written in the answer is he divides the distance between the ice point and the steam point into 100 equal parts. So you calibrated the thermometer. Okay, he divides the distance between the ice point and the steam point into 100 equal parts. Place thermometer in room, and now he can easily measure the room temperature. So this is the second answer. You calibrate the thermometer, and very easily you can find the room temperature. So my dear students, we have reached the end of this paper, and this was October-November 2019 4-1 paper. This was an ATP paper. It has 4 questions, and the time allotted was 1 hour. So I hope that this video will help you to solve this paper. It will be better if you have a hard copy of this paper with you, and you actually solve them and you check them with the marking scheme. So one thing which is left, very important thing, is that you, okay. So let me show you the marking scheme and of the question number 4, because I have not shown that. Okay, so this is the question number 4. What you can do is you can pause the video and you can take your time with this marking scheme. So I hope that this video is helpful to you. If you find this video helpful, kindly kindly subscribe my channel, kindly like my video, and if you find this video helpful and beneficial to you, share the link of this video with your friends on WhatsApp, on Facebook, and on your Instagram. So thank you very much, everybody. It was a great pleasure for me to teach you online. So thank you very much, and have a good day, and God bless you all.